here's what I'm talking about. Basically what I have is a sequence of flip-flops. Let's say M of them, 1, 2, 3 up to M. This is a shift register. So on each clock pulse, elements will be passed down the chain of flip-flops, and I take my output from here. It's a feedback shift register. So below here, I'm going to have some logic connections. Whatever the output of this logic is, I'm going to feed it back into the first shift register. And in particular, the logic will consist of mod 2 addition. But only for some of these taps. Only for a carefully selected number of those taps. What do we call mod 2 addition in logic? Anybody know? Does anyone know what mod 2 addition is? Mod 2 addition is this. 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, 1 plus 1 equals 0. So this is XOR. What is mod 2 addition? If I take mod 2 and get the result. Okay, here's an example. Let's take 3 shift registers. Let's let that be my XOR element, or it's an addition element, but we'll say it's a modulo 2 addition element. So in other words, this is XOR. And we are going to take taps from 3 and 1, and then feed that back. So let's see what kind of an output this will generate. So the shift registers, let's call them S1, S2, S3. First off, let's say I have 0, 0, 0. My output is 0. I'm going to call this output here, N for next. What's N in this case? It's S1 plus S3, which is 0, mod 2, which is 0. So what's the next content of my shift registers? I take these 2 zeros, I shift them over. This N goes in the front. What's my output? 0. What's N? 0. Do I need to continue? It'll stay like this forever, right? So I can initialize this to whatever I want except 0, because this is what's going to happen. So let's try 1, 0, 0. My output is 0. What's my next? I have 1, S1 plus S3, which is 1, mod 2, which is 1. And what's the next content of my shift registers? 110. Output 0. N is 1. S1 plus S3 is 1. Mod 2 is 1. Next content of my shift register is 111. Output is 1. What's N? It's 0. S1 plus S3 is 2. Mod 2 is 0. Next content of my shift registers, 0, 1, 1.
So what's changing the value of S2 again?
Nothing except the shift.
So the shift is, it's
So-
flipping the bit like 0.
No, so 1, 0,
Okay. Oh, I see.
shifts
Okay.
here.
Yeah, yeah, yeah. Okay.
1, 1, shifts here.
Yep.
1, 1, shifts here. Okay, faster. What's the output now is 1. What's N? 1. What's my next shift register? It's 1, 0, 1. My output is 1. N is 0. 1 plus 1 is 2. Mod 2 is 0. My next shift register, 0, 1, 0. Output is 0. N is 0. Then I get 0, 0, 1. Output 1. N is what? 0 plus 1 is 1. Mod 2 is 1. I now have 1, 0, 0. Do I need to continue? Why not? Because it repeats. So once my state is the same, then obviously I'm going to get all of the same sequences of. So if I have M, this is interesting. So the period here is 1, 2, 3, 4, 5, 6, 7. Now if I have 3 flip-flops, what's the maximum number of states that I can have? 8 is 2 to the 3rd power. But I already showed you that 0 was ruled out. So therefore the maximum number of states that I can have is 2 to the 3 minus 1, which is 7. And in fact, this hits all of those 7 states. So this is the longest sequence. This is the longest period that I can have. So in general, if I have 2 to the m minus 1, if I have m flip-flops, and I find a sequence with a period of 2 to the m minus 1, then this is called a maximum length sequence. So what's my sequence here? This is basically it. And I can read that out, and that's my chip sequence, which is 0, 0, 1, 1, 1, 0, 1. Okay, nobody uses chip sequences that are shorter than, that are made with less than, I'd say, 7 or 8 flip-flops. You need a lot of flip-flops to make a really interesting chip sequence. Okay, so this is worth pointing out. Chip sequences, feedback shift register sequences